I'm Professor Indra. Let's look at how we can design experiments in business settings. So the purpose of conducting experiments is to examine causality. When we want to establish causality, we need to control any unnecessary variables. We do that by matching. If we know the unnecessary variables that are going to interfere with the independent variable and dependent variable relationship. If we don't know uncontrolled variables that are influencing that relationship, then we match, we randomize. But if we know the uncontrolled variables that influence, we match those uncontrolled variables in the control group and in the treatment groups. But if we don't know, then we randomly choose subjects so that the effect of uncontrolled variables are equivalent in all groups. So we can collect data for experiments using the 5 senses: observations, interviews, taste, smell, and cognition. What we do in experiments is we manipulate the independent variable, which we call the treatment variable or experimental variable. When we manipulate, we can manipulate in one group, and in another group we don't manipulate, or we can manipulate at different levels. It could be 1 manipulation level, 2 manipulations, 3, and so forth. So what we do here is that we consciously decide how much of independent variable that we are going to influence on the dependent variable to examine the causality by controlling unnecessary variables. So when conducting experiments, we can look at 1 independent variable or 2 independent variables as experimental variables. When we look at 1 experimental or treatment variable, there are different types of designs, 3 main types of design. One is called the true design, then the quasi design, and exposed facto design. Under the true design, we can have, the first one is we can have a pre-test and a post-test for the same subjects. In period 1, we do the pre-test, and after the treatment, we look at the same subjects in the next period, post-test. The second, under the true design, is in the same period, we have a control group where there's no manipulation of the independent variable, and a treatment group where the independent variable is manipulated. We can have a Solomon 4-group design to increase validity, that is, the control group is replicated and the treatment group is replicated. In true designs, it is encouraged, if possible, to conduct the experiments double-blind. That means the researcher doesn't know the participants, and participants don't know the researcher when conducting the experiment. The second is the quasi design. In quasi design, that is sort of partial design of experiments, we can have, there are 3 ways of doing it. First one is pre and post test for treatment group. So we look at the treatment group in period 1 and then look at the treatment group in period 2 and then compare, but without a control group. So It's a quasi design. The second is we look at the post-test only with experiment group and control group. For example, maybe there was a training program that was conducted in the company, and some got the training, some didn't. But 2 years after the training program, we then examine their productivity. And those who did not get the training as the control, and those who got the training as the treatment or experimental group. And then we can compare. The third of the quasi design is where we collect data on a time series. Period 1, period 2, period 3, and period 4. The third aspect, or the third way of conducting one experimental variable study, is ex post facto design. That is where already conducted effect of programs, and then we look at them later on. It's very similar to what I mentioned about the training programs, that we look at after the event rather than before the event. So we can look at the control group only, we can look at the treatment group only, or we can compare the two groups as preferred by the objectives of the experiment. When conducting experiments using two treatment variables or experimental variables, there are 4 ways of conducting those experiments. The first one is completely randomized design. The second one is randomized block design. The third one is Latin square design. And the fourth is the factorial design. So what we mean by factor is an independent variable in experimental designs. And when we say levels, we are actually referring to the levels of the factor or the independent variable. So we can have low, medium, high, and so forth. That is the treatment levels. So the treatment is the levels that we are talking of. A blocking factor is a blocking variable, is a variable that has an influence on the dependent variable, and we know about that. And because we know that, we want to block the influence of that variable in the experiments to find out the causality of the independent variable of interest to us in the experiment. So in completely randomized design, there are 2 independent variables. In this example, there are fares and routes. The experimental variable here are the fares. What we want to know is the influence of fares on the passenger numbers. So we have 3 levels of fares: 5 cents, 7 cents, and 10 cents. But we also have another independent variable, which are the routes. So there are 3 routes in this travel company: route 1, route 2, and route 3. So in the completely randomized design, we have 2 independent variables. Variable 1 is the experimental variable. Variable 2 is the route, which is not experimented. So what we do is, we allocate the 3 levels into the independent variable, which are not experimented. Here, routes are the independent variable not experimented, and we allocate the 3 levels of the experimental variable, which are the fares, to the routes. And then we look at the effect of fares in these routes by number of passengers. The second is the randomized block design. In the randomized block design, we have independent variable, which is the fares that we want to look at the effect on passenger numbers, but there's a blocking variable, independent variable that influences the passenger numbers, which are the residential areas. So we block that factor. The way that we block that factor is we allocate the fares to this blocking factor and then look at the number of passengers by blocking factors. The third is the Latin square design. In the Latin square design, there's experimental variable, which are the fares, but then there are two blocking factors. So in this instance, there's residential areas and then also day of the week. So we block those factors and then we allocate the fares to the matrix of the day against the residential areas, and then we look at the number of passengers in each matrix set. The factorial design is where we have two independent variables, and both variables we want to look at the effect on passenger numbers. So in this instance, we got the bus type as one independent variables, and then the next one is the routes. There are 3 routes, and then we allocate the fares to this matrix of the 2 independent variables, and then we look at the passenger numbers. So for this purpose, our null hypothesis in this instance is that the passengers numbers will not change, will be equal regardless of the route and the bus type. But when the experiment was conducted, we find differences. We find that when in the luxury buses, that there are more passengers traveling when the fare is low compared to regular bus when the fare is expensive, and the least number of passengers travel in regular buses. So we can look at each independent variable in the factorial design and the number of passengers. We can see that when the route fare increases, the number of passengers decrease, and when the bus type from regular to luxury becomes that the number of passengers increase. Then we can also look at the interaction between the 2 experimental variables, that's the bus type and the route fare, and we find that the luxury buses, even when the fares are higher, that more passengers travel in the luxury buses.